They say the continents were once one, but no one remembers how it felt when all the land that ever was touched itself, without an ocean between. Mountains had not yet drifted apart, and the wind carried the same dust across what would become Asia, Africa, and the Americas. The world was not divided, only breathing slowly under one sky. But what did it mean for the earth to be whole? And why did that wholeness have to break? So, before you get too comfortable, take a moment to like the video and subscribe, but only if you really like what I'm doing here. And tell me where you're listening from tonight, and what time it is there. Because time feels different when we talk about a world that once had none. They call it Pangea, from the Greek pan, meaning all, and Gaia, meaning earth. But the name came long after the land had already torn itself apart. When Alfred Wegener proposed it in 1912, he was ridiculed. The idea that continents drifted, that Africa and South America once fit together like two halves of a broken vase, was too poetic, too impossible for the rigid minds of science then. He died in the cold of Greenland, still believing that the world had once been one, but unable to convince the world. He was right. Decades later, evidence began to whisper back to us. Fossils of identical ferns, Glossopteris, found in South America, Africa, India, Antarctica, and Australia. Rocks that matched like separated puzzle pieces across oceans. Mountain chains that aligned like scars that had once met. The Appalachians and the Atlas, the Karoo and the Paraná. When scientists mapped the magnetic stripes on the ocean floor, they realized the planet's crust carried a record of movement. Iron minerals frozen in direction, pointing like compasses toward a truth long ignored. The continents had not been fixed. They had wandered, collided, separated. And the ghost of Pangea was hidden beneath every step we take. But what was it really like? That single landmass under an endless sun? Geologists believe it formed around 335 million years ago. As smaller continents, Laurentia, Gondwana, Baltica, drifted together and collided in slow motion over millions of years. In those collisions, mountains rose like the spine of the planet arching upward. Rivers twisted across vast plains, and deserts stretched for thousands of miles across the interior, where rain could never reach. The supercontinent was surrounded by one endless ocean, Panthalassa, and within its folds lay a smaller sea, the Tethys, where coral and ammonites once glimmered in the shallow light. Imagine standing in the center of Pangea. No coastlines, no tides whispering nearby. Just the long silence of wind, carrying the dust of continents that had not yet learned to be apart. The air was thick, hot, heavy with carbon. Forests clung to the edges where moisture survived. But the interior was a furnace. Dunes rolling for hundreds of kilometers, storms that lasted months. The nights glowed with lightning that danced from horizon to horizon. And yet, life endured. Giant amphibians dragged themselves through river deltas. Reptiles evolved armor and speed to escape the growing heat. Plants hardened their leaves against drought, sending roots deep into the cracking soil. Every adaptation was an answer to loneliness, a way to survive in a world that had lost the cool breath of oceans. Perhaps the Earth itself was learning what it meant to be one and restless. Some scientists say Pangea was inevitable, the result of plate tectonics, the slow dance of crustal plates drifting over molten mantle. But others see a pattern deeper than geology, a rhythm in the planet's heartbeat. Supercontinents have come and gone before. Rodinia, Columbia, Nuna, Kenorland. Each one gathered the scattered fragments of land, fused them, and then tore them apart again. As if the Earth itself breathes in unity and exhales in division. As if continents are not random but cyclical. The planet's memory looping through creation and separation. If that is true, then Pangea was not a beginning, nor an end, but one of many dreams the planet has had about itself. And that raises another question. If Earth is capable of remembering, does it also feel? When mountains grind together and oceans open like wounds, is there pain beneath the crust? Or are these movements simply the expression of something deeper? The slow awareness of a planet alive in time. Wegener's idea was first rejected because it blurred the line between science and imagination. But that line has always been thinner than we think. The Earth's rocks are not inert. They move, crack, melt, and reform. They carry magnetic memories of where they once lay under the sun. Even the ocean's salt records, the dissolving of continents, the tears of ancient rivers. We walk every day on the remains of a unity that has never truly ended. It only changed form. In the fossil record, we can still trace that unity. The bones of Lystrosaurus, a small dog-sized creature with tusks and a beak, appear in Africa, Antarctica, and India. Proof that these lands were once one. The same species crossing regions that would one day be divided by thousands of miles of ocean. Its fossils are like whispers from a world that never knew separation. There's something strangely human in that story. We too live divided by borders, languages, beliefs, yet all our origins trace back to a single source. The world beneath us has done the same, again and again, assembling itself, shattering, drifting, and returning. Perhaps we are not just inhabitants of Earth, but reflections of its own restless pattern. When you close your eyes tonight, imagine this: no continents, no countries, no oceans between. Just one vast breadth of land under an ancient sun. The sky tinted red with dust. The wind moving endlessly from one edge of the world to the other. You could walk from what is now New York to Morocco without ever seeing the sea. You could follow the curve of a single mountain range from Brazil to West Africa and never realize you'd crossed what we now call the Atlantic. That is the secret of Pangea. Not just its existence, but the feeling of a world undivided, humming beneath itself. A memory that has never left the rocks, even after they drifted apart. And maybe, in the quiet spaces between our own divisions, we can still feel that pulse. But if the Earth was once whole, what made it decide to break? Long before the continents learned to drift apart, something deeper moved beneath them. Something ancient, patient, and alive in ways we still can't fully measure. Beneath the crust of Pangea, heat and pressure swelled like a buried pulse, carrying whispers from the mantle. The slow breath of deep time that never stops exhaling. It's easy to think of continents as solid, but they are rafts floating on molten memory, shifting in the dark while we sleep above. Beneath the mountains and deserts of Pangea, those forces were already preparing their quiet rebellion. The surface world, in those early ages, would have seemed eternal. A horizon without edges. The same red dust carried across continents by unbroken wind. The same sun setting over the same desert that stretched for 10,000 kilometers, casting the same shadows it had for millions of years. But deep below, the mantle churned. Heat rose from the planet's heart. Convection currents spiraling like vast invisible storms. And wherever that heat gathered, the crust swelled and cracked. That is where Pangea's story truly began. Not on the surface, but in the fire beneath. Geologists trace that beginning back more than 400 million years ago, to the slow collisions of ancient landmasses. Laurentia, Gondwana, Baltica, Siberia. They moved like sleepwalkers, drifting toward one another at a few centimeters a year. Yet over eons they remade the face of the planet. Oceans closed. Mountains rose like ribs under the Earth's skin. The Iapetus Ocean vanished as Laurentia collided with Baltica. The Rhyic Ocean disappeared as Gondwana folded into them. Bit by bit, the fragments of the world fused into one, like memories merging into a single dream. To understand that process is to think beyond time as we know it. A mountain doesn't rise, it exhales. A continent doesn't collide. It remembers where it came from. The Himalayas, the Appalachians, the Urals, all are echoes of that same gesture, the slow folding of stone into height. And even now, in the minerals of ancient rocks, we can read the heat and pressure that once bound them together. Across what is now eastern North America and northwest Africa, geologists have found the same granites, the same metamorphic layers, the same fossils, as if the land itself had been cut and later glued back together by invisible hands. When we map magnetic minerals inside those rocks, they tell us they once pointed in the same direction, a fingerprint of unity. The continents were never strangers. They only drifted apart long after the memory had hardened into stone. But to imagine Pangea as still is to misunderstand it. It was not a sleeping world. It was a living, moving experiment. The tectonic plates beneath it flexed and pressed against one another. In some regions, subduction zones swallowed entire oceans, dragging their remnants into the mantle. In others, rift zones began to stretch, pulling the crust apart like old fabric. Even in its moment of greatest unity, the supercontinent already contained the seeds of its own undoing. Some scientists call this cycle the Wilson cycle, the endless rhythm by which continents come together, break apart, and come together again. It is the slowest heartbeat imaginable, each cycle lasting hundreds of millions of years. And yet, within that rhythm lies something almost biological. A pulse, a rest, a return, as if the earth itself were practicing a kind of meditation, gathering itself, releasing, then gathering again. When Pangea was whole, it changed the planet's breath. The deep currents of the mantle shifted, redirecting ocean circulation and atmospheric winds. The center of the continent, far from the moisture of any coast, became dry and hostile. Dust covered entire regions where once there had been seas. Massive river systems, like the one geologists call the Central Pangean Mountains drainage, carried red sediments into inland basins that baked under relentless heat. Those same red beds, rich with iron oxides, still color the cliffs of modern Utah, Morocco, and the Urals. They are not just rocks. They are memories of a suffocating sky. But even the most desolate deserts had moments of grace. Fossilized raindrop impressions, preserved in mudstone across what is now Scotland, show where storms briefly returned. Their pattern suggests sudden monsoons, violent and short, sweeping across the continent's heart like breath, returning to lungs long deprived. For a moment, rivers awakened, animals gathered, plants drank greedily. Before silence came again, some paleoclimatologists argue that Pangea's vastness distorted not only weather, but evolution. With so few coastlines and so much interior desert, species were forced into narrow ecological corridors, strips of life surrounded by wasteland. The result was both concentration and fragility. Life that thrived along the edges, but nowhere else. In this way, Pangea became a paradox, a united world that created isolation. A single landmass that made distance infinite. And beneath it all, the mantle continued to turn. The supercontinent rested on a network of subduction zones that drew heat and movement downward. But in the center, deep beneath what is now Africa, a plume of rising magma began to stir. It would take more than 100 million years for that force to break the crust. But it had already begun. That plume, scientists believe, still lingers today beneath the same region, the African superplume, a ghost of the energy that tore Pangea apart. To think of that plume as mere hate misses its poetry. It is the memory of pressure, rising back toward the surface. It is the planet's reminder that stillness is never permanent. Even now, that slow fire shapes our continents, our oceans, our seasons. Every earthquake, every volcano, every trembling ridge beneath the sea is a syllable in the same long sentence that began when the world was one. When we hold a rock in our hands, a granite from Maine, a basalt from Namibia, we hold fragments that once touched, pressed together in silence under Pangea's sky. The atoms within them still remember that closeness. When you place two rocks from opposite sides of the Atlantic beside each other, they sometimes even fit. Grain against grain, fracture against fracture, like lovers separated by time, still shaped for each other. And what if the Earth itself feels that longing? What if every continental drift is not an accident, but a slow act of remembering, a reaching toward something lost? When we map the mantle's convection or model the drift of continents millions of years from now, we call it science. But beneath that science is a rhythm that sounds almost emotional. Perhaps that's why we find beauty in the image of Pangea. Not just geological wonder, but a sense of melancholy. The world was once whole, and in a way, so were we. The magnetic fields frozen into Pangea's rocks show reversals. North becoming south, south becoming north. Countless times over millions of years. The planet's polarity flipped again and again, as if uncertain of its own direction. It's easy to forget that the compass is not absolute. Even the Earth's poles wander. In those reversals lies a strange echo of identity. Even the planet doesn't stay the same self for long. When you listen to that deep pulse, the breath beneath Pangea, it sounds less like a mechanical process and more like an ancient hymn, rising and falling, gathering and scattering. The continents move in phrases, not in steps. Every ridge and rift is part of a melody older than life itself. Perhaps that's what we feel when we look at a map of the world. A sense that the pieces could slide back together, that separation is temporary. The ocean between us, the distance between continents, between species, between memories. It's all the same movement, slowed by time. So maybe the question isn't how Pangea formed, but why the Earth keeps repeating this pattern. Why unity must always lead to fracture. Is it balance, renewal, or simply the way matter remembers change? The crust still drifts. The mantle still turns. And somewhere beneath our feet, the same ancient breath continues. The sound of a planet dreaming of becoming whole again. The air above Pangea was heavy, so thick with carbon and dust that the light itself seemed tired. The sun rose and fell through a haze the color of rust, and even the wind moved slowly, as if burdened by the planet's own breath. To imagine that world is to step into a dream of fire and ice, a climate not yet stable, still searching for its rhythm. Because when the Earth became one land, it also learned the cost of unity. Balance was broken. Extremes took its place. Across the endless interior of Pangea, rain was rare. The supercontinent was so vast that moisture could not travel far from the coasts. The heart of the land, stretching from what would become North Africa through Arabia to modern-day China, was a desert of unimaginable scale. Sand dunes towered like frozen waves, hundreds of meters high, sculpted by winds that carried heat instead of relief. Geologists call this vast wasteland the Pangean megadesert, and its traces still stain the red sandstones of Utah, Morocco, and the Urals. Each grain of sand we find today once drifted beneath skies that had forgotten the scent of rain. And yet, on the coasts and near the Tethys Sea, the climate told another story. Monsoon rains crashed in seasonal violence, carving rivers that swelled and vanished with the tilt of the planet. Fossilized mud cracks, salt pans, and raindrop imprints tell us that storms came not in mercy, but in fury. Entire regions drowning and drying within the same breath of a season. To the creatures who lived there, life was a cycle of extremes. Drought and flood, silence and thunder, heat and sudden chill. Somewhere in the Triassic layers, we find evidence of forests that had adapted to that rhythm. Conifers with thick bark and needle leaves, capable of surviving both drought and cold. Ferns that spread their spores during the brief humid months. Cycads that clung to rocky slopes, waiting for the rare rains to return. These plants were survivors of contradiction, the children of a climate that dreamed both fire and ice. The supercontinent's vastness didn't just shape the weather, it sculpted the air itself. Volcanic eruptions, common along the mountain belts formed by collision, released immense amounts of carbon dioxide. The levels may have been 6 to 10 times higher than today's. The atmosphere became a greenhouse, trapping heat, and the oceans warmed. Yet even within that warmth, parts of Pangea froze. Seasonal ice sheets formed in high latitudes, strange glaciers existing under a global heat. It was as if the world couldn't decide whether it wanted to burn or sleep. In deep time, climate is not chaos, but pulse. Oxygen levels rose and fell. Sea levels advanced and retreated. The record of these oscillations is written in stone, in layers of evaporites, coal seams, and limestone. Each band tells of a shift in temperature, in humidity, in life. The red beds of the Triassic, rich in iron oxide, speak of oxidation under endless drought. The black shales whisper of brief returns to water, of plankton blooms, of oxygen-starved seas that swallowed themselves. Scientists have long wondered how life could persist in such extremes. And yet, the fossil record shows not collapse, but resilience. Early reptiles, small and agile, evolved to conserve water and regulate temperature. Mammal-like creatures, the synapsids, developed new metabolisms to survive the swings of heat. Insects adapted wings to travel further in search of moisture. Even in the harshest interior deserts, footprints of small archosaurs and amphibians mark the edges of vanished lakes. It's strange to think that from this unstable world would rise the age of dinosaurs. But instability breeds innovation. The supercontinent's climate forced evolution to improvise, to become efficient, adaptable, enduring. The creatures of Pangea were shaped by contrast. And perhaps that is the secret to their longevity. When the land broke apart, they carried those adaptations with them. Resilience, mobility, hunger. The records of Pangea's climate come not only from rocks, but from isotopes trapped in shells and minerals. Oxygen isotope ratios in fossilized marine carbonates reveal temperature fluctuations of astonishing scale. At times, equatorial waters reached 40 degrees Celsius, hot enough to stress marine life to the edge. At other times, they drop sharply, suggesting sudden cooling. Such swings may have been triggered by volcanic winters, eruptions so vast that they dimmed the sun for years. Beneath the calm sedimentary layers, the story of climate reads like a heartbeat skipping in panic. It's tempting to imagine that such violence was a punishment, that the Earth, compressed into unity, had become restless with itself. When pressure builds within a closed system, something must give. Even today, scientists studying supercontinent cycles suggest that extreme climates may be inevitable outcomes of geologic union. When continents merge, circulation breaks down. The oceans lose their ability to move heat around the globe. The result is stagnation. Deserts where water cannot reach. Storms where energy becomes trapped. Unity creates imbalance. And yet, within that imbalance, there was also beauty. Imagine the sunsets of Pangea. The sky veiled in iron dust, the sun a copper wound bleeding across endless dunes, lightning flashing through volcanic haze, the smell of wet stone after the rare rain, the way the stars might have looked through the thin veil of carbon-rich air, sharp, unmoving, eternal. The world may have been harsh, but it was not dead. It was awake. Some researchers believe that photosynthesis itself evolved to thrive under such light, that plants learned to use the diffused red glow to harvest energy more efficiently. In a way, even the smallest fern was adjusting to the planet's mood. Everything, from wind to root to bone, was learning how to live inside contradiction. To walk across Pangea would have been to feel the pulse of a planet in tension. Days of unbearable heat, followed by nights of unexpected cold. Sky darkened by ash, cleared by sudden rain. Rivers cutting through stone, then vanishing into dust. The climate wasn't background. It was the protagonist. It sculpted every life, every instinct, every extinction. And perhaps that's why so much of its memory feels familiar. Because we live now in another age of imbalance, a smaller, faster version of what once consumed the ancient world. Rising CO2, collapsing weather systems, dying reefs. We are walking once more inside the rhythm of Pangea, but sped up 1,000-fold. So, maybe the past isn't just a record, it's a rehearsal. The world has burned before, drowned before, frozen and recovered. It knows how to start over, even if we don't. But the question remains, when the climate begins to dream again, will it dream of balance or of fire? The rocks keep their silence, but the wind over the desert still sounds like the same whisper from that lost age, a breath moving between extremes, searching for something it can no longer remember. Before the deserts took hold, before the fires of Pangea's heart turned the skies to copper, there were forests. Vast, green, humid worlds that stretched across the continents like a second skin. Their roots sank deep into swamps so rich in decay that they breathed out their own weather. Heavy mists, the smell of ancient sap, the sigh of wind in leaves that no longer exist. These were the Carboniferous forests, the lungs of the planet, long before Pangea came fully together. Their ghosts still linger in the seams of coal that burn beneath our cities. When we light a candle, drive a car, or warm a house, we are, in a sense, burning the breath of those forests. The memory of a time when trees ruled the earth. In the late Carboniferous, about 300 million years ago, the world was drenched in green. Giant lycophytes towered 30 meters high, with trunks covered in diamond-shaped bark patterns. Tree ferns unfurled fronds the size of sails. Horsetails thicker than a man's leg crowded the edges of dark rivers. Insects, drunk on oxygen-rich air, grew enormous. Dragonflies with wings like kites. Millipedes as long as crocodiles. Amphibians, the first vertebrates to conquer land, hunted in the shallows, where roots and water met. The atmosphere was almost 35% oxygen, the highest in Earth's history, and every spark of decay fed the breathing world. But unity was already coming. The continents, drifting toward one another, changed the planet's rhythm. Mountain ranges rose where oceans once lay, and with them came the long drying of the swamps. As Pangea formed, the climate shifted toward the extremes that would define the Triassic. The forests began to die. In their place came the deserts, red, vast, empty. The coal swamps receded toward the poles, and with each retreat, more of the earth hardened into dust. Yet, not everything vanished. In pockets of moisture along rivers and deltas, forests adapted. Glossopteris, a hardy seed fern, spread across the supercontinent, its leaves now fossilized in rock from India to Antarctica. The same species found on distant lands would one day be Wegener's proof of continental drift. To him, those leaves were evidence of memory, that the earth had once been whole. But to the forests themselves, they were the last breaths of an age ending in silence. If you walked through one of those final forests, you would have seen something extraordinary. The trees, unable to decay completely in the swampy air, left their trunks behind, hollowed by time, hardened by minerals, preserved as stone. They became monuments, not of civilization, but of biology. Entire groves of petrified wood still stand in Arizona, Argentina, and Madagascar, relics of Pangea's twilight forests, their roots anchored in what was once a world of water. When scientists study those fossilized woods, they find growth rings that tell of chaos, sudden droughts, then floods, years of hunger followed by years of abundance. In the stone cells of ancient trees, the climate of millions of years is recorded in silence. And the message is always the same: balance never lasts. The forests of stone are both tombs and testaments, proof that life can turn itself into memory when it has no other choice. Rivers still crossed those dying lands, but they no longer carried renewal, only sediment, red with iron from the oxidized soils. These rivers, sluggish and wide, sculpted the surface of Pangea into canyons and basins. The color of the world changed. What was once green became red, stained by the slow rusting of the planet's skin. That red remains in the sandstones of Utah, the cliffs of Petra, the plains of the Sahara. To hold one of those stones is to touch the dried blood of an ancient world. Within those rivers, life held on. Freshwater fish adapted to low oxygen. Amphibians dug deeper burrows, waiting for floods that might never come. Reptiles, born from the struggle, learned to live entirely on land. Their eggs, protected by hard shells, freed them from dependence on water. With that single innovation, evolution turned the page. The Earth that had been amphibian became reptilian. A quiet revolution written in bone. The forests that died became something more powerful than the creatures that lived. Their remains, compressed over eons, turned into coal, black mirrors of the past buried deep within the crust. Every mine, every ember, every spark we use to light the night is a relic of those vanished woods. We have built our civilization on the carbon of that extinction, on the breath of trees that fell long before humanity existed. In that sense, Pangea still fuels us, literally. And yet, there's something melancholic about that knowledge. That our fires come from forgotten rainforests. That our warmth depends on an ancient death. The Industrial Revolution was, in a strange way, the resurrection of the Carboniferous, a ghost age returning through smoke and steel. We dig into the earth and release its buried breath, not realizing we are repeating the same cycle. Life, Fire. Silence. Some geologists describe the transition between the Carboniferous and Permian as the greening's end. Others see it as metamorphosis. The world shed its forests not in tragedy, but in transformation. By the time Pangea was whole, the planet had entered a new state of being. Leaner, drier, harsher, but alive in a different rhythm. The rivers of red that replaced the forest became arteries of change, carrying iron, dust, and the seeds of evolution. And still, deep beneath those shifting rivers, the coal seams formed, layer upon layer of fossilized sunlight. The earth never wastes its memories. It only buries them until they are needed again. In the same way that mountains hold fossils of marine life high above the sea, the planet constantly rearranges its past, forcing us to confront how fragile permanence truly is. Perhaps the forests understood something we've forgotten, that existence is not about endurance but transformation. To become stone is not to die. It is to enter time differently. The same could be said for civilizations, for species, even for us. We turn ourselves into memory, into artifacts, into stories told around quiet fires. If Pangea had a sound then, it was the whisper of wind through the last trees. A dry wind, smelling of resin and red earth. The rivers carried that dust to the sea, and the sea swallowed it without reply. Above, the sky glowed a strange shade of orange, dimmed by volcanic haze. Somewhere in the silence, evolution was waiting. We walked today among remnants of that age. The coal beneath our feet, the petrified wood in desert parks, the red cliffs that catch the setting sun, all fragments of a world that once breathed as one. They remind us that every end is only a continuation, disguised as loss. And yet, when you stand before a petrified trunk and touch its cold surface, you can still feel the texture of bark that once held light. It's as if the forest never left. It only fell asleep. But if these forests turned to stone to survive, what did the creatures who lived among them become? Why? When the forests turned to stone and the rivers ran red, life did not surrender. It changed its shape. Across the great plains of Pangea, where wind carried dust instead of rain, creatures learned to walk further, breathe less, and endure more. They were no longer bound to the marshes of their ancestors. They belonged to the land now, all of it. From the far north to the southern ice, from what would one day be North America to Australia, the same creatures walked the same soil. The earth was one body, and its veins of life ran unbroken across every continent. To stand on Pangea then would be to see a world both ancient and new. Herds of Lystrosaurus, small, beaked, tusked animals somewhere between reptile and mammal, wandered across open floodplains, digging for roots. Fossils of the same species are found today in South Africa, India, and Antarctica, a proof carved in stone that all those lands once touched. To Lystrosaurus, there were no oceans between them, no borders, only the long wind, the dry soil, and the search for food. It survived the greatest extinction in Earth's history, the Permian, not by strength, but by persistence. When 90% of life vanished, Lystrosaurus walked on, its heavy steps echoing across a continent that still remembered unity. And there were others. Synagnathus, a swift predator with a dog-like head and a mammalian jaw, hunted the same open plains. Dicynodon, squat and tusked, grazed where the last ferns clung to life. These creatures, known as synapsids, carried within them the first blueprints of what would one day become mammals. Their teeth, their warm blood, even the beginnings of fur. In the heat of Pangea, They learned to conserve water, to regulate temperature, to live through droughts. Every adaptation was an act of quiet rebellion against extinction. Fossils from South America to Antarctica tell the same story. The same species, the same forms, scattered across what are now different worlds. Wegener would one day point to these bones as proof that the continents once fit together, that oceans were not barriers, but afterthoughts. But, for the creatures themselves, there was no mystery. They lived in a world of continuity, where the land never ended, and the horizon always led somewhere familiar. Imagine a single step stretching from what is now Texas to Tanzania. No salt air, no coastlines, no division of species by ocean currents. Predators and prey spread in all directions, carried by migration patterns that ignored geography. It was a time of great simplicity, not in mind, but in space. The world was whole, and so was life. The Triassic sun was harsh, the air dry and shimmering, but it was also the dawn of innovation. The reptiles diversified. Early archosaurs, ancestors of crocodiles and dinosaurs, began to rise. Amphibians shrank into shaded corners, retreating from the growing dryness. The earth was turning reptilian, shedding its softer forms. Those that survived were the ones who could seal themselves against loss, scales against evaporation, eggs against decay, lungs built for drought. And yet, for all its brutality, Pangea was not without beauty. In the early morning light, you might see herds moving like shadows across a red horizon, long tails dragging patterns in the dust. The sound of insects, the distant call of something between a lizard and a mammal, the slow rustle of cycads in the heat. This was the music of the supercontinent. Life had become silence given form. To the oceans, things were no gentler. The Pantalasa Sea that surrounded Pangea was both vast and unstable, with circulation slowed by the single landmass. Waters near the coasts became stagnant, suffocating marine life. And yet, in that suffocation, new forms arose. Early ichthyosaurs took to the water, reptiles returning to the sea in search of relief. They were the first whispers of the ocean's recovery, sleek bodies cutting through the warm shallows of the Tethys Sea, eyes wide, lungs full of air that once belonged to forests now turned to stone. Pangea's creatures were pioneers of endurance. Their fossils are found everywhere because they lived everywhere. But beyond their biology lies a quiet symbolism. The idea that life itself resists division. Even after catastrophe, even after the air thickened and the forests burned, life reconnected the world through its footsteps. The same bones scattered across continents are not just evidence of movement, but of memory. The earth remembering its own wholeness through the creatures that walked upon it. Consider the footprints preserved in the sandstones of what is now Germany. The Chirotherium tracks, 5-fingered imprints belonging to early archosaurs. The same patterns appear in South America and Africa. Across time and ocean, they match almost perfectly. These tracks are not fossils of species. They are fossils of motion. The evidence of a world that once moved together, breathing as one. In every evolutionary branch that began on Pangea, there is a pattern of reaching. Species spread outward from a single root, finding new edges of the same land. It is as if evolution itself was exploring the meaning of unity, testing how far connection could stretch before it broke. And when the earth finally began to fracture, those same creatures became the carriers of continuity. As the rifts widened, as the continents began to drift apart, the descendants of these animals would populate the newly formed worlds, carrying the genetic memory of Pangea with them. There is a poetic symmetry in that. When the world was whole, life spread freely. When it shattered, that same life adapted to the fractures, turning separation into diversity. Every species that evolved afterward, every bird, mammal, reptile, is, in some small way, a fragment of that unity, reborn in difference. The bones we find today are time capsules of that moment. In the Karoo Basin of South Africa, skeletons of Lystrosaurus lie in layers just above the Permian extinction boundary, silent witnesses to a world reborn. In Antarctica, their fossils are found beneath ice, proof that the continent once lay in the sun. In South America and India, the same skulls emerge from the same red stone, millions of years apart, yet identical. To hold such a fossil is to hold the map of an ancient connection. The continents are gone, but the anatomy remembers. The curve of a jaw, the spacing of teeth, the pattern of bone sutures, all point to a single origin. Even after the land split and oceans roared between them, those patterns persisted, echoing across generations. Somewhere beneath that story lies a deeper question. Was Pangea merely a coincidence of physics, or was it the Earth's way of expressing a larger truth, that all life, for a time, must gather before it can scatter? Every heartbeat of the planet seems to follow this rhythm. Union, fracture, recovery. The supercontinent formed, broke apart, and yet its essence never vanished. It lived on through the beings that remembered it unconsciously, in every creature that walked, swam, or flew afterward. At night, when the wind moves across deserts that were once swamps, it still carries the same rhythm, the echo of millions of feet walking across one continuous land. The earth remembers its creatures as surely as they once remembered it. But memory, like stone, erodes, and the same forces that gave Pangea life would soon turn against it. The world that had been whole began to tremble again, and from beneath, the deep fire stirred, preparing to end the age of one land forever. There are silences in the fossil record so vast that they feel like erasures, whole chapters of life, gone without explanation, replaced by black layers of ash and carbon. One of those silences came at the end of the Permian, the greatest dying the Earth has ever known. It was not an impact, nor an instant, but a suffocation that lasted thousands of years. The oceans were the first to fall quiet. Before the dying, the seas of Pangea were alive with coral reefs and ammonites, trilobites and brachiopods, fish with armored scales glinting in the sunlight of the Tethys Sea. The water shimmered with color, but beneath that beauty, imbalance had already begun. The continents, locked together, disrupted the planet's breath. Ocean currents that once carried oxygen through the deep began to stagnate. The air above the equator thickened with volcanic gases, and the water below began to lose its life. Then came the fire. Across what is now Siberia, the crust tore open, releasing lava in eruptions that lasted for millions of years. The Siberian Traps, they call them, a province of stone that still stretches over 2 million square kilometers. Through those fissures poured enough basalt to bury the entire United States beneath a kilometer of rock. But the greater disaster was invisible. Gases, carbon dioxide, sulfur dioxide, methane, millions of tons released into the atmosphere. The sky darkened, the air turned acidic, and the seas began to boil in silence. Scientists studying the rock layers from that time find a boundary marked by a sharp chemical signature, a sudden spike in carbon isotopes, a collapse in oxygen levels. Beneath that boundary, the world is full of life. Above it, nearly empty. An estimated 90% of marine species disappeared. Coral reefs vanish for millions of years. Trilobites, survivors of every extinction before, were gone forever. Even microscopic plankton, the foundation of the food chain, nearly disappeared. The ocean itself seemed to stop breathing. When water loses oxygen, it turns deadly. Hydrogen sulfide gas begins to form, a toxin that rises from the depths, green and luminous in the dark. Some geologists believe those toxic plumes reach the surface, spreading into the atmosphere, a planet exhaling poison. The sky may have glowed strange colors, red from ash, green from sulfur, violet from methane haze. Acid rain fell across the supercontinent, corroding the land. Rivers carried the dead into the sea, and on the coasts of Pangea, where once the tides had whispered, the shorelines went still. Fossil beds from South China to Greenland show the same story. Layers of pyrite, a mineral that forms only when oxygen disappears. Whole ecosystems collapsed. The world's chemistry had changed. The oceans were no longer blue, but black. The cause remains debated. Volcanic winters, methane bursts from seafloor hydrates, ozone collapse, or all of them together. What we know is that life itself nearly ceased. On land, the forests already dying turned to dust. The great rivers of red carried that dust into the ocean, feeding algae blooms that choked the last oxygen away. Even insects, the most adaptable of creatures, suffered mass extinction. The Earth had stopped moving, stopped cycling, stopped breathing, and yet, somehow, a few survived. Tiny burrowing creatures, Lystrosaurus among them, endured by digging into the soil and waiting for the air to clear. Microbes thrived in places nothing else could live, feeding on sulfur and lightless heat. The world shrank to bacteria and bones. From that near-zero point, evolution would rebuild. But not for millions of years. There is something haunting in the thought that our oceans, the same ones we know now, once carried the memory of death so total it took tens of millions of years to fade. Even today, deep in the sea floor, black shales from that age still trap the chemistry of that silence. Their carbon ratios are fingerprints of extinction. Their layers are not just rock, but the shadow of a breath that failed. In those sediments, scientists find something else, a clue to recovery. After the Great Dying, traces of new microbial mats appear, layered like the earliest life forms from Earth's beginning. Stromatolites, domes of cyanobacteria, returned, filling the void left by complex ecosystems. It was as if the planet itself was rebooting, rolling back to its oldest settings, rebuilding from simplicity. The event reshaped everything that followed. The extinction cleared the stage for new worlds to emerge, for reptiles to rise, for dinosaurs to dominate, for mammals to one day appear. But in that moment, it must have felt like the end of everything. The air toxic, the seas silent, the soil empty. A planet in suspension. Geologists call this the Great Dying, but the phrase feels too clinical. It was more like a forgetting, a deliberate unmaking of memory. Fossil diversity dropped so sharply that even the trace of evolution itself seems to vanish. Whole lineages disappeared without descendants. The tree of life did not simply prune its branches. It burned them, and yet, beneath the ash, something kept moving. Heat, pressure, the mantle turning, the continents breathing. The same geological forces that had united Pangea still stirred below. Perhaps extinction, too, is part of that rhythm, a clearing before renewal. For the Earth, death and rebirth are not opposites, but twin gestures of the same cycle. When we look back from the safety of time, it's easy to think of these events as distant, disconnected from us. But the same chemistry is returning. The same gases that filled the air at the end of the Permian now rise again, this time from our own hands. Ocean oxygen is falling. Coral reefs bleach and vanish. Methane seeps from thawing permafrost. The patterns match, not perfectly, but enough to make the bones uneasy. It makes one wonder, is the planet capable of memory? And if so, does it repeat its past not because it must, but because we haven't learned how to end the cycle? When oceans die, the sound of the world changes. The heartbeat slows. The air thickens. Silence replaces the pulse of life. But somewhere in that silence, deep under black water, something begins again. Small, invisible, ancient. Life's refusal to stay gone. The rocks from that time are heavy with that contradiction. Endings that are beginnings. Absence that is potential. The basalt flows of Siberia cooled into plains of stone. The seas turned to oil-bearing shales. The carbon of death became the fuel of the future. Even in destruction, the Earth was storing tomorrow. Maybe that's the strange mercy of the planet, that it keeps rewriting itself no matter how many times the page burns. We are the descendants of those who survived the last silence, inheritors of a world that nearly forgot how to live. And as we stare across our own warming seas, perhaps we are hearing an old story being told again. The one that begins with heat, continues with stillness, and ends in rediscovery. Because the Earth never truly dies. It only holds its breath. After the great dying, the world must have seemed empty beyond belief. The air still carried the taste of sulfur, and the seas were dark, still, and strangely reflective, like mirrors waiting for a face that would never return. The forests were gone. The rivers that once carried life now wandered without purpose, cutting through layers of red silt where no roots held the soil. The wind blew unhindered across thousands of miles, whispering over bones that had no names. For the first time in 500 million years, Earth was quiet. That silence was not peace. It was aftermath, the long exhalation after pain. The planet itself seemed to be in shock. No coral reefs grew, no forests rose, no songs of insects filled the air. Even the rain, when it came, fell onto bare stone and evaporated. The Earth had lost its breath, and everything waited to see if it would begin again. Scientists who study this period call it the early Triassic, but names feel too clinical for such desolation. In the rocks, the fossils thin to almost nothing. Whole millions of years go by with only fragments. A burrow, a trace fossil, a few hardy shells. It's as if the record itself refuses to speak, as if time forgot how to write. Some call this the Strangelove Ocean, a term borrowed from a film about nuclear death, to describe waters so empty that even bacteria stop cycling carbon. Life was reduced to its most basic elements, like the faint heartbeat of a patient still hovering between worlds. But slowly, almost imperceptibly, that heartbeat returned. Microbes colonized the shallows first, weaving thin films of green across the rocks. Cyanobacteria began to release oxygen again, clearing the haze of poison that still hung over the water. Then came small-shelled creatures, ammonites and bivalves, their fragile forms marking the beginning of recovery. Stromatolites, ancient as time itself, reappeared where competition had vanished. The planet was rebuilding itself, cell by cell, as though remembering a language it once forgot. It's difficult to imagine such patience. For nearly 5 million years, evolution hesitated. The ecosystems of the Carboniferous and Permian were gone. The planet was writing an entirely new story. In that stillness, new rules were born. Reptiles diversified in the vacuum left by the synapsids. The first dinosaurs, small, unremarkable, began their quiet march into the future. The oceans, once toxic, began to breathe again. Even coral, which had vanished completely, would someday return in new forms. There is a strange beauty in the idea that life rebuilt itself from near zero, that after losing almost everything, the Earth started again with what little it had. But what did it feel like in those first mornings of recovery? Picture a coastline where the horizon is still dim with volcanic haze, the sea black but calming. The sand is hot, colored by iron. In the shallows, small crabs scuttle under the shadow of boulders. A single fern unfurls from the dust near a stream. The world is not healed, but it is breathing again. The fossils of the early Triassic are often small. Simple shells, footprints, the bones of creatures barely the size of your hand. But in their minuteness lies a kind of defiance. They are survivors, architects of rebirth. The Lystrosaurus, that humble creature that endured by burrowing through drought and ash, still dominates the record. In some layers, 90% of all fossils belong to it. The planet, it seems, trusted its persistence more than brilliance. Perhaps endurance was the only wisdom left. Geologists studying the red beds of this time often describe them as bleeding landscapes. The iron oxides that stain the rock are remnants of a world that was still oxidizing, still trying to stabilize itself. The air was thin, the heat unbearable. The interior of Pangea reached 60 degrees Celsius at times, too hot for complex life. The atmosphere's carbon dioxide levels were 5 times higher than now. Yet even in that inferno, photosynthesis continued. Small patches of green appeared, each one a promise. The silence began to change. Not suddenly, but like dawn spreading through fog. Rivers darkened again with algae. Insects returned to the air, tentative at first, then confident. Amphibians laid eggs in shallow pools. In the oceans, ammonites began to spiral upward in their shells, following the sunlight. Slowly, life reclaimed sound. When we listen to the Earth's history, it is easy to focus on the violence, the explosions, the impacts, the extinctions. But recovery is quieter, subtler, more profound. It's in the repetition of waves, the slow growth of coral, the whisper of wind through new leaves. After the Permian, that whisper was the loudest thing left. Some scientists argue that life nearly failed permanently then, that the biosphere came within a fraction of collapsing entirely. But perhaps that collapse was necessary. When an organism loses everything, it either dies or redefines what it means to live. The same is true of planets. Earth's recovery reshaped evolution forever. The new species that emerged were tougher, faster, more adaptable. Out of the silence came resilience. There's something almost spiritual in that. The notion that survival is not just endurance, but reinvention. The planet's memory was wiped clean, but in that emptiness it found clarity. The next age, the Mesozoic, would be defined by dynamism, by movement, by life that could migrate, evolve, expand. Out of one of the darkest chapters in history came the Age of Giants. But that would take time. For now, there was only stillness. A fragile peace earned through fire. When you touch a piece of early Triassic rock, you can feel that stillness. It's different from other layers, less crowded, less noisy with fossils. The minerals are simple, the grains fine, as though the Earth itself was resting. Those layers are the planet's breath between words, the pause before the next sentence. And maybe, in a way, the same thing happens to us. After catastrophe, there is always a silence, a strange calm that feels like death, but isn't. It's the moment before new life begins, before the next idea, the next form, the next evolution. The Earth teaches that renewal requires quiet, that rebirth demands the death of certainty. The silence after everything was not the end of life, but the beginning of consciousness. A planet remembering how to live again. If you could stand on Pangea then, under that pale red sky, and listen carefully, you would hear nothing at first. Only wind. Only the faint hiss of dust moving across stone. Then, maybe, a distant ripple. The sound of water lapping against the shore. A breath. The earth exhaling. And in that sound, almost too faint to notice, lies the oldest promise in the universe. That even after everything falls silent, something will always begin to sing again. Out of the silence, a faint rhythm returned. Not a roar, but a whisper. The earth began to breathe again. You could hear it in the slow bubbling of oxygen rising from green algae, in the flutter of small wings over the shallows, in the sigh of wind through the first new forests. It was the Triassic dawn, the fragile rebirth after the longest sleep the planet had ever known. The air was still heavy, the sun still dim with volcanic haze. But life, cautious, persistent, had decided to begin again. The landscapes of early Triassic Pangea were raw and wounded. Rivers carved through red deserts, their banks streaked with iron. The great mountains that once rose from the collisions of continents were eroding, feeding sediment into valleys where new lakes shimmered under a pale sky. The seas, once black with suffocation, had cleared just enough to glimmer blue again in the light. The coral reefs were gone, but new reef builders, sponges, algae, and small shell-forming organisms began to grow on the remains of the old. They didn't reach far, just a few meters high, fragile and scattered. But they were proof that the world was no longer dying. In those shallows, ammonites spiraled once more. Small fish darted through the water, cautious of the shadows above. The first marine reptiles, sleek as knives, cutting through the warm waves. Symbospondylus, Nothosaurus, Shonisaurus, creatures neither fish nor land beast, had returned to the sea their ancestors had left. They were strange, elegant, built for a world relearning how to move. Their eyes were large to see in the dim light, their lungs strong to hold breath between depths. They were proof that life not only recovers, but adapts to the ruins it inherits. On land, the transformation was just as profound. The survivors of the extinction had multiplied, filling every empty niche. Lystrosaurus still wandered, but new forms began to appear. Small, upright reptiles that moved with unexpected grace. Among them were the first dinosaurs, unremarkable at first glance. Bipedal, light-boned, fast. They were not yet the giants they would become, but they carried within them the seeds of dominance. The Earth was preparing for a new age, though it did not know it yet. Forests returned, thin and sparse at first. Ferns spread like carpets across the riverbanks, and ginkgos lifted their fan-shaped leaves toward the dim sun. The air smelled of wet stone and sap. Conifers grew in clusters, forming the first forests since the world burned. With them came insects, beetles, dragonflies, and cicadas, buzzing softly through the stillness. The color green, lost for millions of years, began to reclaim the land. The oxygen levels rose. The temperature stabilized, though barely. Seasons began to return, marked by subtle shifts in wind and rain. Monsoons returned to the Tethys coast, bringing floods that nourished the soil. In the heart of Pangea, the desert still stretched unbroken, but even there, life was finding footholds. Burrowing reptiles, hardy shrubs, the beginnings of resilience. It's hard to describe the pace of such renewal. To us, it would have seemed motionless. But over millions of years, The planet was changing its tone, from the low hum of recovery to the quiet rhythm of growth. What we now call ecosystems were rewriting themselves, species interlocking again like the gears of a clock finding its balance. In that process of rebuilding, new alliances formed. The roots of plants partnered with fungi to share nutrients in poor soils. Early mammals, small, nocturnal, descendants of the synapsids, learned to nurse their young, to hide from predators, to live in shadows. The planet was inventing tenderness again. Life, having learned how fragile existence could be, began to protect itself in gentler ways. Paleontologists sometimes describe this era as the long sigh of recovery. In the strata, you can see it. A gradual darkening of rock color as organic carbon returns. A slow increase in fossil diversity. It's like watching the planet inhale. For the first time since the Permian collapse, the carbon cycle restarted. Oceans circulated. Rain fell regularly. The biosphere was breathing again. But even in renewal, there was unease. Beneath the crust, heat still stirred. The same forces that had shattered the world once before were waiting. Continental rifts began to stretch across Pangea's interior. Subtle fractures, invisible to the creatures above. The Earth's heart had awakened, and though life flourished, the land beneath it was already planning to move again. The continents never sleep. They only rest. Still, for a brief moment, everything was in harmony. Pangea, though wounded, carried life on its back once more. Oceans and deserts coexisted. Predators and prey balanced each other, and the air shimmered with the scent of rain on red stone. It was not paradise. It was persistence. And persistence is its own kind of grace. When you look at fossils from the early Triassic, a fern frond preserved in ironstone, a reptile footprint hardened in mud, the spiral of an ammonite fossilized in limestone, you are looking at the handwriting of survival. Each layer of rock is a sentence written by time. The earth is alive again. There's a lesson in that, perhaps, that life doesn't recover by erasing the past, but by building upon it. The same rocks that once recorded death became the foundations of renewal. The same ashes that fell from the sky became soil. The planet never forgets. It transforms. If you stood by the shores of the Tethys Sea then, as the world was breathing anew, you might have felt something sacred in the air. The pulse of a living planet rediscovering itself. The wind would have smelled of salt and pine resin. The waves would have glowed faintly at night, lit by plankton returning to the surface. The stars, clearer now that the ash had settled, would reflect on the calm water like a memory of light. You could have watched the horizon and seen both past and future at once. A world rebuilt from ruin, and beneath it, the restless engine of change still turning. Perhaps that is how renewal always feels. Fragile, temporary, and infinite all at once. A breath that could stop at any moment, yet somehow never does. The earth had begun to breathe again, but deep below, in the fractures forming unseen beneath Pangea's skin, the next transformation was already waiting. A slow cracking that would one day divide the world forever. Even as the forests returned and the oceans shimmered with new life, something beneath Pangea was stirring. The world above breathed again, but the world below was restless. Deep under the crust, where pressure meets fire, the planet's mantle was shifting, slow, invisible, unstoppable. It was the soundless prelude to separation. For millions of years, the surface remained calm, but the foundation was already cracking. The earth was remembering how to move. The land we call Pangea was not meant to last forever. Supercontinents, geologists say, are temporary harmonies. fleeting arrangements of drifting plates that will one day break apart again. The Earth's crust floats upon the molten mantle like ice on a dark sea, and heat, trapped beneath, always seeks release. When that heat accumulates, the ground swells, fractures, and tears. What begins as a hairline crack in the desert can become, given enough time, an ocean. It began quietly. In the heart of Pangea, volcanic plumes rose from deep within the mantle, pushing against the crust, thinning it from below. The first fissures appeared near what would one day become the Atlantic and another near East Africa. But no creature alive could sense the change. The surface looked the same. Forests, rivers, deserts. Yet underfoot, the ground was warming, stretching. Over millions of years, those fractures deepened into rifts, and molten rock began to seep upward. The Earth was breaking its own silence. The geologic record captures this transition like a scar. Across the supercontinent, volcanic deposits known as flood basalts appear. Thick, dark layers of hardened lava spread across thousands of kilometers. The crust, under immense tension, cracked in vast lines that would eventually define the shape of future continents. What is now eastern North America began to drift away from northwestern Africa. What is now South America pulled from what would become West Africa. The puzzle pieces we see on maps today began to loosen then, like a body stretching after too long in sleep. For the creatures above, this was imperceptible. The dinosaurs that now wandered the Triassic plains, Colophysis, Plateosaurus, and their kin, lived out their brief lives unaware that the ground beneath them was moving. Rivers shifted courses, new mountains rose, lakes formed where none had been. To them, these were just changes in landscape. To the Earth, they were the first signs of rebirth through division. Wegener, long after, would trace this motion through fossils and rock, arguing that continents drifted across the globe. He would be mocked for it, dismissed as a dreamer. But he was right. The evidence was written in the minerals, in the matching magnetic stripes across the sea floor, in the alignment of mountain ranges torn apart, in the mirrored coastlines across the Atlantic. The continents were not static. They wandered like fragments of memory. It's strange to imagine the ground beneath us moving at the speed of fingernail growth, yet carrying the weight of entire worlds. We think of the Earth as still, but it is never still. Even as you read this, the continents are drifting. Eurasia moving north, the Pacific shrinking, the Atlantic widening. The legacy of Pangea's fracture continues beneath our feet, slow as thought, vast as time. Some scientists say the break began along zones of weakness left over from the supercontinent's birth. The same forces that once joined the continents had built fault lines deep within them. These dormant scars, reawakened by heat and pressure, guided the splitting like invisible maps. The Earth does not forget its wounds. It grows along them. When those cracks opened, the planet changed in more ways than geography. Ocean circulation shifted again, and with it, climate. The deserts of central Pangea began to shrink as coastlines formed and humidity increased. The red sands gave way to lush deltas, and the world cooled. The atmosphere thickened with moisture. Rain returned to places that hadn't known it for tens of millions of years. From separation came renewal, but the separation was not gentle. The Central Atlantic Magmatic Province, one of the largest volcanic events in history, erupted as the rift widened. Lava covered vast regions of what are now North America, South America, Africa, and Europe. Ash filled the skies, blocking sunlight for years at a time. The extinction that followed was smaller than the Permian catastrophe, but it marked another turning point. Old species vanished. New ones took their place. Out of this fiery division came the dominance of the dinosaurs, who would rule the Earth for the next 150 million years. It's a paradox repeated throughout history. Unity breeds stillness, and stillness breeds pressure. To move forward, something must break. Pangea's unity had made the world stagnant. Its fracture brought circulation, climate, and evolution back to life. Perhaps the same is true of everything. Even civilizations, even ideas. Too much permanence becomes a prison. The cracks beneath us are not flaws. They are the beginning of movement. When scientists study the mantle plumes that caused Pangea's breakup, they find that they still exist. Vast columns of hot rock rising from near the Earth's core. One sits beneath Africa today, another under the Pacific. They are ancient, deep, and slow, like the memory of fire itself. Some geophysicists believe that one day, these plumes will gather the continents again, pulling them into a new supercontinent, Pangea Ultima, Amasia, or Novopangea, depending on which model you follow. The cycle will repeat. The Earth will unite and divide again, as it always has. But if that future world forms, it will not remember us. The lines we draw, the nations we build, the boundaries we defend, all of it will drift away, erased by time and pressure. The continents will meet again, and whatever lives then will walk across a world that has forgotten its past divisions. Sometimes I wonder if the Earth's restlessness is its way of preventing stillness, of ensuring that nothing living can ever grow complacent. The planet keeps changing its shape, and in doing so, forces life to change with it. Perhaps that's why evolution never stops. The ground itself demands renewal. Imagine standing in the center of that ancient rift, feeling the faint tremor of something vast below. The ground swelling, cracking, sighing. The air smells of ash and salt. A thin mist of steam rises from fissures, glowing orange at night. You would not yet see an ocean, but you would sense one coming, a presence forming beneath your feet. The Earth beneath Pangea was learning to breathe differently, to exhale through fire. The cracks beneath our feet are not just geological. They are reminders that nothing whole stays whole forever. Even the most complete world must fracture to grow. Pangea was the last time the planet was one body. Its breaking was not destruction, but release. The slow exhalation of a world rediscovering motion. And as the continents drifted apart, something unexpected followed them. The first signs of complexity returning. The diversification of life that would fill the world once more. The Earth had learned how to breathe. Now it would learn how to sing again. But in the wake of those cracks, as the land divided and the seas widened, the planet began to speak in another language. The language of vibration, of sound, of movement. Beneath every earthquake and ripple, there was music forming. The hidden song of a moving Earth. Every time the Earth moves, it sings. Not in notes or melody, but in vibrations that echo through the mantle. A frequency so low that no ear can hear it, yet everything alive feels it. The cracking of stone, the deep roll of subduction zones, the shudder of plates sliding against each other. Together they form the planet's quiet symphony. Even silence, it turns out, has a rhythm. The song began the moment Pangea started to break apart, and it has never truly stopped. Geophysicists call it seismic noise, the continuous hum of Earth's interior. Recorded by instruments, it sounds like the breathing of something enormous, a slow oscillation between pressure and release. Beneath every continent, that pulse moves. It is the reason we have mountains, oceans, and seasons. The surface of the planet, all our history, all our life, rides upon this invisible music. And during the time of Pangea's fracture, that song was louder than ever. As the supercontinent began to tear, the crust flexed and trembled. Entire mountain ranges groaned under their own weight. The vibrations could travel thousands of kilometers, through rock, through water, through the molten mantle itself. To live on Pangea then was to exist on an instrument still tuning itself. Every quake was a note, every eruption a drumbeat, every shifting fault a slow movement in the planet's composition. In some sense, we still hear it, though we call it something else now. The rustle of wind in trees, the waves striking the coast, the rumble under our feet during an earthquake. These are only fragments of the same song. Each part of the earth translates the vibration differently. Rock becomes tone. Water becomes resonance. Air becomes whisper. Life evolved within that sound, carried by it, shaped by it. We are not separate listeners but instruments in the same orchestra. Back in the Triassic, when the crust was young and restless, these vibrations shaped the planet in literal ways. The energy released by tectonic movement changed climate and circulation. When the crust cracked, it allowed gases to escape, carbon dioxide rising into the sky, influencing weather patterns. Volcanoes erupted in cycles, sending out ash that cooled the planet, followed by warming phases when greenhouse gases thickened the air. The Earth was composing through contrast, tension and release, cooling and heat, silence and noise. And through all of it, life adapted to the rhythm. Fossilized trees show growth rings that echo climatic pulses. Coral skeletons carry rhythmic bands that match ancient temperature cycles. Even the shells of ammonites reveal patterns that correspond to seismic oscillations. Microscopic ridges that record vibrations felt through the sea. It's as if biology was keeping time to geology's music. Modern instruments can still detect that song. A constant background hum at a frequency of 10 millihertz, caused by waves colliding across the oceans and deep tremors resonating through the mantle. Some scientists call it the Earth's heartbeat. It never stops. It has been playing since before Pangea existed, and it will continue long after the continents have drifted again into some new configuration. If you could stand somewhere quiet enough, perhaps in the center of an empty desert or deep beneath the ocean floor, and could somehow hear that hum amplified, it would sound like breathing. Long, slow inhalations and exhalations of stone. It's a reminder that the planet isn't solid in the way we imagine. Beneath the crust, the mantle flows like honey over millennia, carrying heat from the core to the surface. Every eruption, every tremor, every mountain is part of that circulation. When Alfred Wegener first dreamed of drifting continents, he imagined them sliding through the ocean floor like icebergs through water. He didn't live to know the full truth, that the crust moves atop the mantle's slow convection, a current as vast as time itself. In the 1960s, when geophysicists mapped the seafloor, they found ridges and trenches that matched Wegener's intuition. Mid-ocean ridges, like long scars, where new crust was born. Deep ocean trenches, where the old crust sank. The planet was recycling itself, endlessly, in a circular motion of creation and destruction. That cycle is what creates the Earth's song. Every plate boundary, every collision, every separation, releases energy into vibration. Some waves travel quickly, some slowly, but all together they resonate through the entire globe. Seismologists can map the interior of the Earth using those vibrations, reading its structure like an X-ray made of sound. The song tells them where the mantle rises, where it sinks, where the core ripples. Sometimes I wonder if ancient myths sensed this. So many civilizations spoke of a world that trembled. A serpent beneath the ground, a drum at the planet's heart. In India, it was said the earth rested on the back of an elephant, standing upon a turtle. In Norse myth, Yggdrasil, the world tree, shivered with each quake, its roots touching fire and ice. These weren't errors of imagination. They were interpretations of vibration. Before science, humanity could already feel the planet's rhythm and gave it names that matched our own pulse. And isn't it strange that the same deep forces that built mountains also beat in our chests? Our heart's rhythm, 60 to 100 beats per minute, is a tiny echo of tectonic timing, the contraction and release that defines all living systems. In us, it's blood and breath. In the planet, it's magma and motion. We are scaled fragments of the same song. The continents still move to that rhythm. Satellites can now measure it. Millimeters each year. Continents gliding apart as if breathing out. The Atlantic widens by a few centimeters annually. And somewhere in the far future, a new Pangea will form again. The cycle will continue. Silence, pressure, fracture, renewal. But for now, the Earth hums quietly beneath us, unaware that we have given names to its movements. Every earthquake is a reminder. Every volcanic plume a verse. The tectonic plates slip and grind, and the song continues, shaping everything we see yet remaining inaudible. It's the oldest music in existence, and the only one that never stops playing. If you ever find yourself standing on a cliff overlooking the sea, try to listen, not with your ears, but with something deeper. The sound of waves striking the rocks, the vibration under your feet, the faint tremor in your bones. It's all the same note. The Earth's voice, speaking softly through stone. And maybe that's why silence can feel alive, because it isn't silence at all, just the lowest possible note, vibrating below awareness. A reminder that even when nothing seems to move, everything is still in motion. Beneath Pangea, that motion became the seed of the world we know. The planet had begun to sing, and life, unknowingly, began to dance to its rhythm. But the song carried another melody too, faint and unfinished, the memory of unity. And as the continents drifted further apart, that echo, that longing, would return, not through rock, but through myth and memory, as if the earth itself still remembered being whole. When the continents finally drifted apart, they did not forget. Beneath the seas that filled the spaces between them, beneath the silt and salt and coral, the memory of Pangea remained, a pattern etched into stone, a quiet magnetism buried in the crust. The continents may seem like strangers now, but deep beneath their mountains and rivers, their rocks still remember the touch of one another. Every coastline is a wound that once fit perfectly. Look at a map long enough, and you can see it. The way South America leans into Africa like a missing half. How North America's east once brushed against Europe's west. How Antarctica and Australia once shared a forested bridge. These shapes are not coincidence. They are the remains of a lost embrace. Geologists call the study of this memory paleomagnetism, the tracing of the planet's ancient field lines preserved in stone. When lava cools, its magnetic minerals align with the direction of Earth's magnetic field at that moment, freezing orientation into the rock. Millions of years later, when continents move, those frozen compasses point to where they used to be. Through them, scientists can reconstruct the dance of drifting lands, the positions of poles, the forgotten geometry of the world. The rocks, in their silence, keep time better than any clock. But not all memories are scientific. Some are human, echoes in myth, carried across cultures that had never met. Nearly every civilization that rose along the new shores of the world told stories of a lost land, a single place where everything began. Atlantis, Mu, Lemuria, the lands beneath the waves. These myths, scattered across continents, feel like shared dreams. How could people divided by oceans imagine the same idea? That once there was one world, now broken and drowned. Perhaps the mind, like the planet, remembers in its own way. Long before geology, before compasses and maps, there was the feeling that something had been lost, that humanity had arrived after a great separation. Across millennia, that longing became mythology. We named it differently each time, but the shape was always the same. A world that fell apart, and the desire to return to it. In southern India, ancient texts speak of Kumari Kandam, a vast land connecting the Indian Ocean's rim, home to the first civilization, swallowed by the sea. In the Pacific, Polynesian stories tell of Hawaii, the ancestral homeland lying somewhere far beneath the waves. The Greeks imagined Atlantis, destroyed by the anger of the gods. In each story, water takes the land, a poetic mirror of what actually happened when the Earth's crust broke and the seas rose between fragments. Myths, perhaps, are the soul's way of recording geology. Even now, scientists find evidence of those buried connections. Fossils of identical species on separate continents, strata that match perfectly across oceans. The same coal beds appear in India, Antarctica, and Africa. Seams of ancient forest that once stretched unbroken across Gondwana, Pangea's southern half. In Norway and Greenland, the same mountains meet again, torn apart by the Atlantic but still aligned like halves of a sentence. It's as though the continents, though separated, are still trying to speak to each other through stone. When seismic waves travel through the Earth, they cross boundaries that were once united. The waves slow in familiar regions, speed up through foreign ones, as if recognizing what was once the same. The Earth's interior is full of such conversations, vibrations traveling from one fragment to another, carrying old signals like forgotten language. But memory isn't only geological, it's biological too. The DNA of species tells a similar story. The lungfish of Africa and Australia, though divided by oceans for hundreds of millions of years, still share ancient genes from when their ancestors swam in the rivers of one land. The plants that bloom in South America and Southern Africa bear pollen grains that match like twins. Even the patterns of rainfall, guided by mountain ranges that once shared foundations, echo the rhythm of their old alignment. The continents remember, but so does everything that grew upon them. Sometimes, when you stand by the sea and watch the horizon blur into sky, you can almost feel that memory rising through your feet. A faint vibration, an ancestral longing. Maybe that's why we are drawn to the ocean, to its endless distance. Somewhere deep inside, we remember crossing that distance without ever leaving land. It's easy to imagine that the Earth's memory is geological, but maybe it's emotional too. A kind of longing built into the nature of matter. Every mountain that matches another across the ocean is a message. I was once part of you. Every island chain curving toward another is an unfinished thought. Even the magnetic pull between continents, faint, measurable only with instruments, is like the echo of attraction that never entirely disappeared. Perhaps that's why, even in the modern world, humanity keeps imagining ways to return to unity. We build bridges, ships, networks of communication, invisible continents of connection. Maybe we are repeating the planet's oldest instinct, acting out its geological nostalgia through our technology. And maybe this memory of wholeness is why separation hurts, why nations and people, like continents, fracture and drift and still ache for reunion. In that sense, the Earth is our mirror. It teaches that all unity is temporary, but also cyclical. What is divided will someday find its way back together. Geophysicists predict that, in about 200 million years, the continents will reunite into another supercontinent. Whether it forms around the equator or near the poles, no one can be certain. But its name has already been imagined. Pangea Ultima, the last gathering. The circle will close. The old memory will become real again. In that far future, the Atlantic will close, the Pacific will vanish, and mountains higher than the Himalayas will rise where the oceans once lay. New deserts will form where green forests thrive today. Humanity, if it still exists, will stand once more on a single unbroken world, walking over the ghost lines of the first Pangea. The memory will have become flesh again. Until then, the continents continue their slow drift, like lovers who once fit perfectly, but now move in opposite directions, carrying fragments of each other within their hearts. Every earthquake, every ripple across the sea floor, every tremor under our feet is part of that long conversation. The sound of the planet remembering itself. When night falls and you look at the stars, remember this. The land beneath you once touched every horizon. Every step you take is upon a piece of something that used to be everywhere. And when the wind blows from across the sea, carrying the scent of another continent, maybe it's not distance you smell, but recognition. The earth whispering to itself across time. Because even after 200 million years, the continents still remember each other. And maybe, in the quiet beneath our noise, so do we. The story of Pangea did not end when it broke apart. It merely paused. For the Earth, separation is never final. It is only an interval between unities. The continents drift now as they always have. Slow, quiet, inevitable, tracing long arcs across the surface of the planet. Every inch they move is part of a rhythm older than time, a breath that expands and contracts, drawing the world together, then letting it go. Someday, they will meet again. Someday, there will be another Pangea. Scientists have given names to the possibilities. Pangea Ultima, Amasia, Novo Pangea. Each is a dream of what the Earth might look like 200 million years from now, when the current chapter of movement ends and the next begins. Each is an attempt to imagine the world's return to itself. In one version, the Atlantic Ocean closes, swallowing the coasts of the Americas and Europe, drawing them together once more. The Pacific, ancient and vast, vanishes beneath subduction zones, its crust consumed by the mantle. Africa continues drifting north, colliding with Europe to raise mountains higher than the Himalayas. Australia drifts westward, merging with Asia. Antarctica, no longer frozen, joins the assembly near the equator. The continents unite again in a ring of mountains surrounding a single inland sea. A mirror of the first Pangea. In another vision, called Amasia, the continents gather around the North Pole. The Arctic Ocean disappears, replaced by a supercontinent crowned in ice. It is a cold unity, a frozen one, where seasons are extremes and light never settles. There, the Earth remembers its symmetry, but through silence, through snow that never melts and nights that never end. No matter which map proves true, the result is the same: reunion. The crust will heal its fractures, the mantle will exhale heat beneath new ridges, and the scattered edges of the world will touch again. But what will it feel like, that future Earth? What kind of life will walk upon it? Perhaps it will be a world of heat once more, like the first Pangea, an immense desert wrapped around the equator, red dust stretching from horizon to horizon. The oceans will withdraw into one vast basin. The interior will be dry, scorched, and restless beneath a sun brighter than today's. But even in that harshness, there will be beauty. Strange forests adapting to long droughts, new seas shimmering at the edges, creatures evolved to breathe thin air and drink rare water. Life will endure, as it always has, by inventing itself anew. Or perhaps it will be a colder world. If the continents unite near the poles, glaciers may spread across half the land. Mountains will shimmer under eternal frost. The winds will howl like memory itself, carving valleys that once were seas. The oceans will be fewer but deeper, their currents looping around the single landmass in slow, spiraling currents. Evolution will follow the rhythm of ice, slow, deliberate, enduring. Whichever form it takes, the next Pangea will be both a reunion and a reckoning. Because in every union, there is tension. The Earth will store heat beneath its massive crust, waiting to escape. The same pattern will repeat: birth, stillness, fracture. The supercontinent will last for millions of years, but not forever. The planet will tear itself apart again, just as it always has. It's the heartbeat of geology, unity, division, renewal, and yet, there's something profoundly human in imagining this cycle. Perhaps we project our own longing for return, our wish to come home, to erase distance, to become whole. The Earth's continents drift, but so do we. Families, languages, civilizations, scattered by time and motion. And maybe, deep down, we share the same hope, that one day, the fragments will find their way back together. When scientists model the next supercontinent, they are not only tracing the movement of plates, but predicting the continuation of memory. They are describing the planet's instinct to close its own circle. Even if no human remains to witness it, the reunion will happen. The continents will move with the same slow certainty they always have, and the Earth, without witnesses, will remember what it feels like to be one again. It is strange to think that the same forces shaping our continents, the same invisible drift we can measure by satellites, are the forces that once determined who we are. The location of a continent changes its climate, its life, its species, its civilization. If Africa had not collided with Europe, the Mediterranean might not exist. If India had not crashed into Asia, there would be no Himalayas, no monsoon. Our histories, our myths, our empires, all of them are products of geology. We are the children of drifting stone. And someday, when the continents merge again, new species will inherit the consequences. The atmosphere will change. Circulation will alter. Evolution will accelerate in new directions. Perhaps intelligence will rise again. Not human, but something else, shaped by a world of singular land and vast sea. They will look across their planet and see no borders, no separate lands, only one endless horizon. Maybe, in that far future, they will feel what we can only imagine: the stillness of a unified Earth. By then, the sky will be different too. The sun will have grown hotter, larger. Days will shorten as the Earth's rotation slows. The moon will have drifted further away, making tides weaker and nights darker. The constellations will no longer resemble the shapes we know. Everything will have changed, and yet the planet's pattern will remain the same. The great cycle of assembly and dispersal, the breathing of continents, will continue, unbroken. There's a quiet comfort in that inevitability. Long after we are gone, the Earth will still be writing its slow poetry, shaping its surface with patience no life can match. Every fracture we know, every mountain we climb, every ocean we cross, all of it is part of a rhythm that never ends. The continents have been lovers, rivals, exiles, and kin. They meet, part, and meet again, each time forgetting why they ever drifted apart. When you look at a globe, you're not seeing geography. You're seeing motion caught mid-gesture, a planet in transition, a sentence unfinished. The next Pangea is not destiny, but continuation. The same story told once more in a different age, with new life to interpret its meaning. Perhaps when that time comes, the Earth will look up at its own sky and wonder, as we do now, how many times it has lived this cycle before. And perhaps it will whisper to itself, through the wind over new mountains, through the waves on its single shore, I remember, because the future supercontinent is not only about the shape of the Earth, but the persistence of memory. Every drift, every fracture, every reunion is a reminder that nothing, not even separation, can erase the instinct to return home. And when that home forms again, under a sky brighter and stranger than ours, it will not be the end of history, only another breath in the endless respiration of stone. When the world finally settles again, after continents have drifted, collided, and rejoined, the Earth will look quiet from above. One land, one sea, one slow, deep breath turning beneath the sun. But beneath that calm surface, within the oldest layers of stone, something continues to hum. A vibration so faint it seems almost imaginary. It is the memory of all that came before. The memory beneath the silence. For the Earth does not forget. Its crust is a palimpsest, each age written over the last, yet never completely erased. Under every desert lies the outline of an ocean. Under every ocean, the ghost of a mountain range. Deep inside the mantle, fragments of crust older than life still circulate, rising and falling in the slow heartbeat of geological time. Nothing is truly lost. It only changes state, from land to sea, from stone to dust, from memory to silence. Scientists have traced tiny anomalies in seismic waves, patches of ultra-dense material resting above the core, drifting slowly with the mantle. Some think they are remnants of the plate swallowed during Pangea's birth and death, pieces of the ancient crust that refuse to melt. They move unseen, like thoughts deep within the planet's body. If one could listen closely enough, perhaps their motion would sound like the faint echo of an earlier world turning in its sleep. And if the Earth remembers, perhaps it dreams too. Every continent we know today, Africa, Asia, the Americas, Antarctica, was once part of something whole. The separation gave us diversity, but the memory of unity never faded. Even now, the magnetic minerals and rocks still point toward vanished poles, preserving the direction of fields that no longer exist. Every compass, whether human or mineral, is drawn not only toward the present north, but toward all the norths that came before. In that sense, the Earth's memory is both geological and spiritual. A reminder that what we call progress is only motion within a larger cycle. Every mountain that rises will one day sink into the sea. Every ocean floor will one day become sky. The boundary between creation and destruction is thinner than we think. The planet erases itself tenderly, as if revising a story rather than ending it. If we could see time as the Earth does, we would not speak of endings at all. We would see instead the slow folding of events, the return of patterns, the repetition of themes. What we call extinction is only transition. What we call loss is only transformation. Even silence in this view is not absence, but preparation. The pause before another song begins. There are places on this planet where that memory rises close to the surface, where you can almost hear it. In the deserts of Namibia, the dunes glow red from the same iron that once colored Pangea's rivers. In the Appalachian Mountains, the stones still carry the pressure of the African collision that built them. In Antarctica, beneath the ice, coal seams lie buried, forests frozen from a time when the continent was green. The planet speaks softly through these relics, telling anyone who listens, I have been many things, and I will be many more. Sometimes I imagine the Earth not as a sphere of rock, but as a mind, slow, vast, full of forgotten thoughts. The continents are memories, the oceans, emotions that shift and return. The magnetic field is its intuition, invisible yet guiding. Volcanoes are outbursts of recollection, sudden, uncontrollable. And we, the temporary consciousness living on its skin, are simply one of its brief dreams. When we vanish, the Earth will continue thinking in silence, turning through space with the patience of eternity. That thought should be terrifying, yet it isn't. There is something peaceful in it. The idea that our existence, fleeting as it is part of something that never ends. Every word spoken, every step taken, every fire lit, all of it returns to the soil, to the ocean, to the air. We are not apart from the cycle. We are the way the planet remembers itself in detail. We are the shimmer of awareness on the surface of deep time. In the quiet of night, when wind moves over stone and the ground feels still beneath your feet, you are standing on layers of ancient motion. Beneath you lie the bones of old mountains, the ashes of vanished seas, the crushed remains of creatures whose names have been lost for 200 million years. And beneath them, deeper still, the heat of memory, the fire that never sleeps. If you could press your ear to the ground and listen long enough, you might hear it. The slow murmur of minerals rearranging, of continents whispering to one another across faults, of the planet speaking to itself in frequencies lower than thought. That sound is older than language, older than life. It is the same hum that carried through Pangea, through every world before it, through every silence after. And in that hum, there is no beginning, no end, only return. Perhaps that is the real meaning of Pangea. Not a continent, but a condition of being. The Earth as one body, every part connected to every other, moving, separating, remembering. Even when broken, it remains whole in spirit. The same could be said for everything that has ever lived here. For us, for all our histories and divisions. Beneath the surface of separation, something still unites. The rocks remember unity, the oceans carry it, the wind repeats it. Every storm, every tide, every earthquake is the planet rehearsing its oldest song, the one about coming together after falling apart. The verses change, but the melody remains. So when the world grows noisy, and the days feel small, and the future seems uncertain, imagine this: a planet that never stops breathing, never stops remaking itself. The continents will drift and collide again. The oceans will widen and close. The stars will move overhead. And somewhere, deep beneath it all, the same quiet pulse will go on, undisturbed, and maybe one day, far beyond our own time, when the next Pangea rises under a different sky, some new form of life will walk across that land and feel a strange sense of recognition, as if they, too, have been here before. They will stand on the same stones, breathe the same recycled air, and look at the horizon that never ends. They will not know our names, but they will carry our dust within them. And the Earth will remember both them and us. equally, as part of its single, endless memory. Because beneath all the noise of life and death, there is something that never fades. It is the sound of stone remembering its shape. It is the pulse of water carrying stories across time. It is the breath of a planet dreaming itself whole. And when everything falls silent again, that hum will still be there. Deep, steady, eternal. The memory beneath the silence.